everyone. We're going to get started in just a couple more minutes. Just waiting for people to join in.
Hello, AB.
Hi, AB. Welcome to Hacky Hour. Okay, I think we have a pretty solid group now, so I think we're ready to get started. So hi everyone, welcome to Always Coding, our weekly Hacky Hour. I'm Komal Devjani, a developer advocate with alwaysAI. You might have seen me at other Hacky Hours or other webinars. And I just want to hand it off to Steve for a quick introduction.
Yeah, I'm Steve Grisette. You usually see me over on the webinar forum. Sometimes, I've answered some questions here, but I'm the CTO with alwaysAI. So nice to meet everybody in this forum.
Thank you, Steve. Yeah, so today's topic is really focused around data manipulation using NumPy and lists. So we're going to see how we can kind of filter out results, and then Steve is going to go through a more detailed overview of NumPy and some other interesting stuff. So we'll get started. I'm going to share my screen now, just a moment. So if you haven't done so already, you want to make sure you are signed up for alwaysAI. If you want to know how to do that, you just go into alwaysai.co, and you should be able to sign up when you see the login link here. So click login and then sign up. Once you're in, you would be able to see your dashboard. So we're going to pull that up. So as you can see, I've created this simple object counter here. I want to delete this project and create a new one just to show you how it works. So we're going to click create a new project, and we're going to call this the simple object counter. And this is a object detection starter app. So we're going to click create project. And then from here, we're going to click view your project. And once you're in the dashboard, you will have the opportunity to download the CLI for your Mac or PC. You want to make sure you have this downloaded. As it mentions here, the Mac installer will prompt and quote unidentified developer warning. You would just need to bypass that. If you're using Mac, just click show in Finder and then open in Finder, and that'll allow you to bypass that, allowing you to install the CLI. And then if you're using Windows, it'll just give you the option to run the app anyway.
And then the nice thing, Kamal, on that, I'm going to make a commentary, is sure. We had our Edge IQ development meeting this morning, and Eric's going to get that solved with our next release. So that's the cool thing, so that you don't have to do any jumping through hoops with the installer. So that'll be really helpful.
That's awesome. That's actually really good news. So yeah, I guess this is the last time I'll tell you about this warning. Hopefully soon you won't have to deal with this anymore, and you can just download the CLI. One more thing I want to point out about installing the CLI, you want to make sure you have the latest version available. If not, you can just download the CLI, and that'll update the version for you. So from here, as you can see, we're using the MobileNet SSD model here. So what I want to do is let's go into my terminal, and I want to go into my alwaysAI directory. And then from here, I'm going to go into the alwaysAI starter apps. Now, I just kind of want to point out something about, sorry, just a second. So we're going to go from here into this simple object counter. So I just want to point out something about the object counter here. As you can see, the object counter app.py file has all of these objects indicated here, where all of these objects are available with the MobileNet SSD. We are only looking for these 4 things. And alwaysAI has tooling available for you to be able to filter out specific objects. And this starter app already has that embedded in it, but if you wanted to incorporate that as part of your real-time object detector, just want to show you how you can find that as well. So we're going to go into Docs. And in Docs, we're going to go under Tools. And from here, if you scroll down, you see that there is results filtering. And the command that we're going to use is filter predictions by label. So that basically matches what we have here in the starter app. Now, it's only going to filter for these objects, which are indicated earlier on in the code. So with that said, we're going to get started. We're going to do a quick AAI app install. And it's install the app, and from here, we're going to do the AAI app start. Okay, that seems to be working great. So I'm going to copy this and paste it into my browser. So as you can see, it can detect me. So it detects one person, kind of detects my potted plant, not really. All right, there it go. And then I have one more here to show you how it can count. So as you can see, it shows 2 potted plants, 1 person, 0 chairs, and 0 sofa. And that's all I have to share. And now I want to hand it over to Steve to go into NumPy and lists.
Thanks, Kamal. And then the thing that I think is, host, you got to help me out here. Can I go ahead and my screen? And there we go. We're going to go to desktop 1, I hope, and share. And then I'm going to ask my Eric, do you see Catalina Island by chance?
Yes, I do.
Okay, good. But the other powerful thing about that filtering is, let's say you have a lot of noise in the objects you want to count. That API and the service behind it, what it will do is when you're in the prototyping phases and you haven't gone through the transfer learning phases of model retraining, it will let you focus in on just the things you want to see. And it's a nice API to have on that piece. So I just wanted to point that out. So, but let's get started on that. So today, what we're going to do is we're going to go and take a look at an application we're actually working on with a customer. We'll look at the early prototype of it. And it's one of the ways in which you can use computer vision in manufacturing processes. And a lot of those, I should just say, a lot of those are around making sure that the work that you want done is done. So, and computer vision is great for verification on that type of work. There are other implementations, such as if you have like a depth camera or even just a regular camera and so forth on robotics processes for something like an Amazon, well, it doesn't have to be Amazon, but anybody's warehousing facilities, pickers are another good example of that. But you can even use OpenCV to, if you have humans doing the picking, to make sure that they have picked the correct thing. So again, this is a good verification app. And then I'm going to actually, this is the command line, I'm actually going to start out on the Raspberry Pi because I want you to see some of the performance criteria of that too as we start the application. That the Raspberry Pi is a fine platform to use, particularly if you marry it with the Myriad CV or Myriad accelerator from Intel, which is what I'm going to do, which we call the NCS2 chip or stick. Eric's shown you that in the past. And then also what I would recommend, use a Pi 4 with either 2 gigs or 4 gigs of memory. They're all getting cheap now on that. So that way you don't have to swap to the SD card. I shouldn't use them. They're getting inexpensive. So that's the better word to use on it. So with that said, let's go show what we're gonna take a look at more closely today. And then I wanted to do one last thing, and that is not the right thing I wanted to bring up. So I'm gonna bring this up. And I just wanted to make sure that everything we're doing today is stored in a GitHub. So you just need to go up and clone the GitHub. All the applications are underneath Hacky Hour and then the date for today. almost the date for today. I'm missing a 0. so it's close to the date, but everything's up there for you to go to try. This particular folder has the Pi one that is used for the NCS2 device, and then if you just want to do your Mac and PC, that there's a app for that too. That has some interesting things. So enough said right here. Let's go into that. So I'm going to go into that folder. I've already cloned it. I'm going to go in and I'll see the listing. I want to go into Tray Pi. So I'm going to go into Tray Pi, and you have to spell it correctly actually to go into it, I think. And it's going to, now we should be able to do it okay. No, what am I doing wrong? Huh. Oh, you have to actually go into the directory where you, no, that's the tray program. I should not. Okay, this is fun, guys. LC. I see it. Eric, anything I'm doing wrong here that you can tell me?
No, I don't know. Yeah. Oh, it's
All
tray.
right.
It's tray RPi. Yeah, instead of tray pi.
Ah. Okay, so there you go. So I apologize with people. Steve needs to learn basic skills and maybe needs better glasses. That's what we've learned today on this. So I'm going to go ahead and
Are you able
start
to
this.
make your terminal a little bigger so that
that should happen too. So maybe I need the terminal actually be a little bigger myself too. So sorry about that, everybody. So there we go. Is that good for everybody?
can you make it a little bit bigger?
Yep, we can do that. We have the technology if I do it right. Highlight that. And yes, I can. I'm having the demo gods are not with me today. And I'm going to do the same thing. Here, let me go ahead and do this. And there we go.
Perfect. Thank you.
Okay. So hopefully that has got it. So I'm going to go ahead and start the application. So, boy, I'm having a good day. So there we go. And we'll go over here on the video and we'll start it. So let me tell you a little bit about this application. So the application is using the HSV color spectrum to find, and we'll talk about this later, to find the area of region, what's lit up in the container. And then what we're using is we have an object detection model for hand detection. And what we're looking at is crossing rectangles or intersecting rectangles to make sure that are overlapping rectangles is probably the best way to say it, to make sure that the person is grabbing the right piece to this. So it's pretty straightforward on this. And as you can see, they can grab really quickly. Now the model detection, and this is coming up, the model detector, we took the generic one that's up there, and what we've done, and you can still see some holes in it. This is the early prototyping of this application. Is that what we've done is we've run it through our model retraining. And there's going to be model retraining webinar in August. And I encourage you all to come because we're going to have those modules in there. And then we're going to have a lot of hacky hours around that and show people what to do on that, because that's one of the core pieces of a computer vision algorithm. So there you go. So it's red when the person doesn't touch it, and then when the person does grab it, it turns green. So pretty simple and straightforward. Now, what I do want to point out, this is running on the Pi. And if you notice, it's inferencing around, well, in the 50 millisecond range. Sometimes it pops to 60s, but it's going pretty well. So for people that are hesitant on wanting to use Raspberry Pis, I would say, please go ahead. So what we've seen on this application as we work with its customers is it got plenty of speed for this. And then you're going to get all kinds of casing components and so forth. And you have a huge community around this particular single board computer. And then the camera itself is actually very good for the application. So you have a nice, inexpensive camera sets, or a whole plethora of inexpensive cameras you can put around this system. So they are very, very good for building these type of manufacturing applications. So what I want to say is we've used OpenCV to do HSV and some other pieces. We've used NumPy, and then we'll show where we're going to use lists. So a lot of what I want to cover today is how we use those things in the application. And so what I want to do is, it sometimes can get very confusing moving through how the different systems react and so forth. And so I wanted to kind of just talk at a very high level. And I apologize to people if this is going to be too basic, but I want to go through a set of slides and really talk about it, because in our everyday coding lives, Eric and I always have to think about this, because it's different than what we were trained in from our basically junior high school on through college mathematics. So it's a different way to look at the world in some aspects. So anyway, Camille, can you kick those slides off, do you think? All right, so what we're doing is building manufacturing using OpenCV and NumPy, and you know who I am, so we can move past the title slide, I think. So let's talk about, first of all, color spaces. So in this application, when we run it on my Mac, I can show you what's happening with the color spaces. You have the RGB, and we all know the RGB, what that has, it allows you to mix colors together to make other types of colors and so forth. So it's something we're actually used to experiencing in our world as we look at things. The red, green, blue color spectrum has 3 channels, and you make combinations of those to do that. Now, the problem you have is your intensity, your light. So what I'm going to talk about, your black and your white that goes into the color, is embedded in those RGB parameters. So as you move into sunlight, as you turn in overhead lights, as you turn off overhead lights, it affects those primary colors that you're working for. And so it can be a problem if you're trying to detect something like those LEDs in your application. So there's another color spectrum called lab. And what lab does is it separates out those 3 variables in a different way. It takes the intensity, so how much black and white, or how much really black is in the system, and it separates it out into its own channel. And then it starts to make out of your green and magenta and your blue and yellow color spectrum on that. So that's one option there. We actually use lab to try to do this one in the first place. It didn't really work well for this application. Now, there's a next one, and you're going to see very little information on it, because I've never used it. And when you come on these things, you never want to talk about something you really have never worked with or used. But it is called the YCR-CB color spectrum. And the best I can tell you, and this means I looked on Wikipedia, the best I can tell you is they've used this color spectrum in it's used a lot in TV transmission and video transmission to do compression, and particularly over the air is where it got most popular in color TV transmissions and so forth. I've never worked with this spectrum, so again, I can't tell you much about it other than what I saw on Wikipedia. So on that. But what gets really interesting here is the HSV color spectrum. And my slide translation, I give for all things, I usually give PDF over to Camille, and then she puts it into PowerPoint. So this didn't translate all that well. So we kind of have the S and the V together there instead of having three dots. But anyway, getting back to what we're talking about, the HSV side is hue, saturation, and value. And so what they do in this one, and why it's kind of nice, is your color is separated out into its own channel. So your red, green, blue, purple, everything like that is put into the hue. So you can start to move away from the hue spectrum. You don't have to worry about it as much. And what you can focus on is what your lighting conditions are going to be. And that's around your saturation, which how much is white into the hue system, how much white is in the color value, and then the color, shades of color, and then your value system, which is your black, how much intensity is around them, how much black is added into that color. So it's a great way to work in lighting systems, and I would recommend it, and so forth for your applications. Give it a try, and then OpenCV is very good about giving you that ability, and we'll look at it in the code, how to translate from those color spectrums. So we'll move forward to the next slide. All right, so we're going to talk a lot, and I know people will say, well, what about 3 dimensions and things like that? We're working with image processing. So we're really talking about a 2-dimensional space today. We'll cover 3-dimension as we get into spatial AI, which is going to be something we're going to do in future webinars, and particularly we hope around the OAK-D camera that you saw out there. We're going to be spending a lot of time in the September-October frame around the OAK-D, so it's coming. But anyway, so we went to 7th grade or whatever it is, or, you know, and what do your teachers teach you? They teach you the Cartesian coordinate system. And really, in 2-dimensional space, what's that mean? We have a y-axis and we have an x-axis. So we have axes, and if you're really fancy, you say the y and x-axis are orthogonal to each other. What that means is right angle to each other. So, but what's interesting here is how the coordinate systems are done. So you have axes, but the coordinate systems are your x-axis are talking about columns. So, and your y-axis is talking about rows. So when you talk about XY coordinates in the Cartesian coordinate system, you're talking about your x-axis, which is represented first, which is about moving across the rows or columns, excuse me. And then you have your y-axis, which is about moving up and down your rows. So I did say that right. So rows, X is rows, excuse me. And is that right? So no, I reversed myself. X comes first, and it's really about moving across the columns, and Y is about your rows. So, sorry, see, that's why I get confused. I have to think about it all the time. And the last thing I want to point out is your origin, you know, your 0, 0 is down in the left-hand corner of the axes. So if I can get Carmel to do it, it's down there in that little left-hand corner with their little thing down. That's where your origin does. And trust me, this will come back to haunt you later as we discuss different systems here. So let's move on to the next slide. And if you have any questions, I see Eric has got things going. So NumPy has axes too, is what I want to point out. But what gets interesting about this is, first and foremost, your origin is going to be up in the top. And Kamal, let's get you have the arrow today. So sorry, it's going to be up there. That's where your origin is. So your 0, 0 point is up there on the top left corner. So you have to really start to think about your algorithms when you do that. Where your x-axis, no change, right? No change. But or I should say your 0 axis in this case, your column axis is where you have your problem. Or excuse me, your row axis is where you have the problem. I'll get it straight, guys. So your row axis is where you're going to have your problem. As you move down towards what was the Cartesian coordinates, you're starting to go up in value. And as you move across, it's the same. So like I said, just watch that as you're doing your different algorithms of what your Y value is going to be. So like in the case of the rectangles overlapping, you're going to see a sign reversal from what you were taught in your basic trig course, I think the first week. So on overlapping rectangles. Okay, so the other thing that's interesting here is if I take some of the functions, like let's say NumPy has some great functions, and one of them is summing, or a mathematical type of formula. So let's say I wanted to sum the rows down underneath the different columns. So what you would think is I would want to sum somewhere down the x-axis and something on that type of thing. But actually what you want to do is you're going to put sum, and you're going to do it down the 0 axis. And so what happens is that's going to collapse everything into a single array. Okay, and that array will contain the sums of all the columns. So you're going to be collapsing, and it's very important, down the different axes down the 0 axis to find your column sums. Now, similarly, if you wanted to sum the row values, then you're going to collapse the matrix into a single array down the axis 1. So I know that gets a little confusing and everything else, but it's just the way that the NumPy system set. Similarly, if you have a matrix, and it often is done, that you're using, and you want to know what's going on with how many columns and rows you have in that matrix. When you take the shape command, the NumPy shape, what you're going to get is the first thing you're going to get a column reading and then a row reading, right? And so this is very important. So your XY is shifted on you in this case. So no, it's not. So sorry, your XY is fine. So your X is going to be your rows and your Y's is going to be columns. And I think that is a shift. Yeah, so it's shifted from the Cartesian coordinates. And like I said, that's why I always have to think. And so I probably confused you, but this is what I want to make as a point. So your XY here is your X is going to represent rows in NumPy, and your Y is going to represent columns. Where in the Cartesian coordinates, it's the reverse of that. So next, and like I said, I can see Eric's typing away and so forth. So we're getting some questions. So now we come to OpenCV. And so what do I want to say about OpenCV? It's interesting, okay? So OpenCV uses what they call the image coordinate systems. And I just put that in quotes because I don't know if it's, just an OpenCV term or what. So it basically is still what we call a row forward language, and most languages are what we call row forward when they come to processing. And I'll have to go to you electrical engineers. I think they do row forward because I think you light up your memory. It's efficient on memory access and so forth. But Eric, you're the electrical engineer. You can make any comments later on that, whether that's actually true or not. I don't know.
Yeah, something like that.
Yeah, so that's what I hear. I'm not an electrical engineer, so I am not going to comment on that. I'll let you guys tell me why I'm wrong or right on that. I just heard things. But anyway, so it is a row first, but your row happens to be, in this case, the Y coordinates. And then your X is your column, and they do a YX first, right? So when they talk about, and you're looking at a coordinate system with an OpenCV, you're doing image manipulation, you're usually on the YX coordinate system. So, and where NumPy is going to correspond everything to XY. And it's just something to think about when you're moving between the two systems and so forth. Now, if you're a C++ coder and working with OpenCV, this hits you the hardest. Now, OpenCV generally uses the image coordinate system, except for when you're accessing a specific data point. And like I said, a lot of C++ coders do this, and then it becomes an XY. Now, where do we see this as Python coders? We see this when we want to draw things. So like today, we're going to draw some circles up here, right? So it's going to ask you for coordinates in XY because it's going for a specific point to find the center of the circle. And you'll see that when you're drawing rectangles, right? It'll ask you for coordinates in XY system. So that's the interesting thing about OpenCV, is that it's mostly an image coordinate system. But sometimes when you're accessing specific points or working with something, it goes to an XY coordinate system. So anyway, so that's my brief introduction to OpenCV and so forth. PyImage Search has an excellent book on this. So if you get the basic book from PyImage Search, they spent a ton of time covering these two things. So we'll do that. So I think I'm going to take over screen sharing at this point in time.
Steve, actually, we have a question from Dale Hitt.
Okay, so let's come in there, Dale.
Hey, Dale. Dale, you should be able to speak now. Oh.
Can you hear me?
Yeah.
Yeah, so I guess you were discussing these axes, and is there some issue in switching between them? I didn't get why you're spending a lot of time on them.
Yeah, so it gets more when you're working with the programs and so forth. So again, between NumPy and OpenCV, they just kind of they reverse the X and Y coordinates compared to OpenCV when you're doing image processing.
Is there just a function that you can use to?
Yeah, so and we'll even talk about it. It's called transpose, right? So because NumPy, and so let's go over what NumPy. So great questions too, Dale. and you're going to require me to give the context of why the hell I talked about this in the first place. Sorry, I just swore on Hacky Day. So, but anyway, so as you're looking at data sciences, you'll have things like in Python, you'll have pandas, and if you want to do some advanced mathematical type of operation, you have scikit-learn or SciPy, right, where you do everything from Fourier analysis and things like that. What NumPy does and why we like to work with it at OpenCV, because we're really working in the image space and things like that. And what are images at the end of the day? They're matrices. And so what a NumPy does is it is a matrix operational system. So you don't have to write all that code. It's highly efficient. It's a C++ code with Python veneer on top of it to call through the API system. So it's hugely powerful. And so when you say you want to switch, because it's a matrix type system, you can do just a simple NumPy transpose. And we all know from our linear algebra classes that transpose, we're just going to flip the axes. So, and that way you can kind of keep when you're doing operations with NumPy and OpenCV, you can make that move. And then that way you can normalize either to, very easily into the standard OpenCV when you're using NumPy. Does that make more sense, Dale, to get some more context to you there?
Yeah, thanks.
Yeah, so really, and that's the point. If I come up, there's this whole, and that is, I'm gonna constantly bring up the wrong one. If I come over here and you go, there's a whole, it's a numpy.org, there's a whole site in there to talk about all the different functions they have. And it's a really great system to use, like I said, when you're doing large matrix operations, and keeps you from having to write the linear algebra behind that. And we'll see in the code where I use a lot of NumPy to do things, and we'll talk about that. And we'll talk about some of the operations that I used in this application to do OpenCV pieces. And so I think what I want to do from here, if we can, let's walk through the code. That might be some.
Oh, you're not sharing your screen yet.
Okay, so let me share my screen so I don't do this privately. And so we'll come back here. So I'm going to go ahead and open up system here and get over here. So this is the application at its core, and it's very simple. Not Lila had a much more elegant code system, I think, last time, that did a lot of interesting things. But this is basically a very straightforward application, and really there are one basic class and two functions that we're using in this program, and let's go through those. So when I want a point system, I just had made this class point, and we could argue whether I needed to do that or not. It just makes it easy for me to take XY coordinates and make them into a point. So, and where do we use that point? It's used a lot when we're using the different drawing functions within OpenCV. So that's why I did that one. So the next one is overlapping rectangles, and this is just where where you look for the false conditions if it's on the left-hand side of one rectangle is on the left-hand side of the other. Like I said, this is a basic trig algorithm. And then the other one is if one rectangle is above the other. Now, what gets interesting in here is if you looked at this algorithm in your trig book, these signs would be reversed. And the reason is what happens is your trig book is on the Cartesian coordinate system, and we're using the OpenCV system where the origin point, or we're using the OpenCV system / NumPy system. And that is where your origin is going to be in the upper left-hand corner. And that's where I said with your algorithms, you need to watch on that, and you may need to make some adjustments. So that's where I've made the adjustment there. The next thing is the detect ROI. And so if we remember what am I doing there? I'm detecting the region of interest. Where is the container that the person is going to pick up a part for that's working on that manufacturing line? So this is just simply detect ROI. The interesting things here is collecting in the LED the min and max y coordinates and x coordinates and the max ones. And we'll show you where that goes in. You put it in. We had a utility that we worked with them on that basically is very simple utility that collects regions of interest, and basically this height is in this parameter. We saw that the height is about 60 pixels that we want on that one, and this is just using a tool to count pixels and show it and saying this is what we see on average to be good and where we can get rectangle detection. This is the crafting part that happens. And then on the color side, we just selected blue as our color. We could have selected anything else. It's just a standard RGB color system here that we have. So, and then basically you take those and then that's going to give you a rectangle, and you return the rectangle and the frame with the rectangle on it. So now let's go through, and again, we're answering the questions offline, but if anyone has questions, we can raise our hand. But now let's go into the main function where most of the work is. So in the past, based webinars and here, we've looked at standard object detection. So if we go through the first part of this, we're simply loading up our standard alwaysAI detection class here, object detection class, and selecting the accelerator, or not really the accelerator, but where we want to do the inferencing on this. And ultimately, when we use the default, the accelerator. So right here on this particular one, we're choosing just simply to use the CPU as the main engine here. If I go over to our Raspberry Pi and we go down and look on this, what we've done is we're using OpenVINO as our accelerator, and that's one of the main differences between the two programs. So that's the change there. So now pop back to this one we're talking about. So we'll go through this. And then this is, we just do this as a matter of coding style. We come in and just so that we know what's going on for us and remind us, we always just print out and say, okay, we're using this model, which we have here, our hand detection. We're using this engine, we're using that accelerator, and here's our label set. And that's just simply, you don't have to do that, but we just like to do that. We've kind of made it our coding culture here at OpenCV when we're doing applications. So the next piece is the boundaries. And so the boundaries are for the HSV program. So how do we detect that LED in the space and focus in on that LED space? And so, and there are programs, and again, I'll share, we didn't share this because this is part of the tooling we did for the company, but there are many things out there, and I'll get to Kamel and I'll share on some of the, like LearnCV, Satya Malik's a blog has how you can build the detectors to do this and run those. But this is something that we built for this company, and so we just didn't feel like we should share it. It felt like that it was more of something they did on the project with us. So, so this, what it does is it gets us, after that long thing, is it gets us the HSV parameters, so the min max of those. So we've used this detector and we've narrowed it down to focus, and we'll show this. Just the HSV pieces of the image that have these boundary conditions, the min max, sit in this edition. So this is the min max of the hue, 60 to 68. That's the colors we're looking for, color spectrum, and then within the brightness and so forth, it's 74 to 187, and then on this thing, 226 to 225 on the black. So what you can see here is that probably, you know, these two parameters, the first two, play the biggest difference in what we're seeing. Well, it's probably pretty close, but that's how we get it. Now, we've shown you the streamer many times. So this is just sending our frames per second. And what we've done is we've shown you how to start the streamer within the with statement. And what that does is default to a 640 by 480. And this one, I want you to see what's going on in the HSV spectrum. So I'm going to be using something called HStack out of NumPy. And what HStack allows you to do is stack up images and so that you can see different images that go on. And in either, if you're using OpenCV's image system, or if you're using our streamer, it allows you to place those together and show those side by side, either vertically or horizontally stacked. So the 640 by 480 didn't really do it for me. So what I did is I'm starting the streamer in what I'll say is a non-traditional way. Okay, and I put that in my hand quotes there. And so what I'm going to do is set the width at 900 here, and I'm going to set the height at 720, and then I just tell it to set up those parameters on the streamer. So we don't have these documented except for in this code. So, but they are there for you to use. So you're getting, so this is a true hacky hour. So you're seeing something in our system we haven't really shared with you guys out there. The next thing that I wanted to talk about, and I'm going to lower the size here, is we're using a video today. And so we've always gone to using the streamer through using the webcam, right? And so everyone says, what about file video stream? Okay, you get your wish today. So in this program, we're going to use the file video stream. And so let me go ahead and kind of show you that, and we can talk through it. So if we go over here and we go to our docs, so we have the file video stream. And so here we have a couple of very interesting options that I want to talk about if we look in the parameter section. So one thing is we allow buffering in the video stream. So you can set your buffer size, so it'll buffer in so many frames and it won't drop before it starts to drop them. So we have that in one of the parameters. So you can set your queue size on the buffering, or you have the option which we're using today to play it in real time. And you would set that with true, and then it will ignore the queue size and it will run it. But it will drop frames when it's running in real time if it gets saturated and so forth. So that's one of them. The other thing is, and we'll talk about where this comes in the code. So everything looks the same as anything you read from the webcam, except for you have this more function. And the more function checks to see whether you're at the end of the file. So, and we're going to use that when we go into our main while loop of the program. And I'll show you how to use. But those are the two most important things, whether you want to buffer write into the queue for your file stream, and then to make sure you use the more statement to detect the end of the files. So that's just what I wanted to show you, and then we'll go back to the code. So we come in and we start our FPS, and then we come into here, and then we use our with statement to start and to initiate or instantiate our video file stream object, and then to start it. And then we'll start our FPS. Now we come into the while that I was talking about. And so instead of, you usually see when you're in the video, while true, right? And in this case, what you're going to see is while file stream dot more. So you change that true statement to be the more statement where it's checking. Then the next thing is I have two labels, either background or hand, right? And so what I'm doing here is, and I'm trying to convince Eric to do a hacky here, a hack session, and one of his upcoming ones to show you how to do custom color maps. But I did a punt here. I only have two colors that I have to, or two labels I have to do with. So I didn't do anything of trying to create anything fancy with the data dictionary to do customized colors. And there is information in the docs on how to do that, but I think it'd be fun for him to show you that. So I took a little punt here, and I basically put the background of this, set the background to white, on the labeling, which, by the way, the detector is taught to ignore, right? It will ignore the background, and then set it to red as the default. I then put a grab status. So on the grab status, it's just simply telling me whether to use one verbiage or another verbiage in the streamer on the side, to whether a person's grabbed it or not grabbed it. And then, of course, we have to read in our file stream. Now, when I read in our file stream, here we go. This is the color conversion in OpenCV, and you can do different things with this. And so in this case, I'm going to convert my image from blue, green, red. And so I know you're saying, Steve, we talked about RGB. So let me tell you the other weirdness about OpenCV. OpenCV works in a blue. So they've taken the RGB color scheme and they've rotated it on its axis. Why? I don't know. I don't know why they did this, but they did do it, and you have to pay attention. So it uses blue, green, red. So this is also helpful if you have a red, green, blue coming in. Sometimes you're working with that you want to make blue, green, red. Now, the good news is we've never wanted you to think about this in alwaysAI, because it weirds us out, weirds everybody out to do that color thing. So we automatically make that color change for you when you go to any of our machine learning systems that we have as classes. So the good news is you don't really have to worry about this. Now, if you used another system, well, you don't have to worry about this. I'm going to leave it at that. I'm not going to go out of bounds here. But in this case, you do have to worry about it because we want HSV. And so what we want to do is take our blue, green, red, which is what OpenCV works in, another, like I said, non-normal thing, and convert it to HSV. And so OpenCV has this very nice function. So if I want to take the blue, green to gray, I just do BGR to gray, and that will change my image. So great function. Now, moving from there, we're going to go into our for loop, and our for loop is going to be used to do a lot of data manipulation here of what comes in from this HSV spectrum. So the first thing we're going to do is we're now going to, take a look at our boundaries. So we're going through here on the for loop, looking at our lower and upper boundaries, and we're going to go through and have some fun here. So for the lower and upper boundaries, we're going to come in and we're going to use NumPy here again. So if you remember up here at the top, I set NumPy as NP, and this is pretty standard to do because coders are all lazy and we don't want to spell out NumPy, so we've made NumPy NP. So, and by the way, you'll see everybody do that. And it's pretty common. So we come back and we set it to MP. And so what we're going to take is those boundaries that I put in there, these two boundaries up here in the system, and we're going to convert those into NumPy arrays because we want to work with them. So we want to work with them in the matrix scale. So what we do here is we convert those boundaries into, and this is our into an array, to NumPy array, and we want to make it an unsigned, so you can assign different data types. We want to make it an unsigned int. So now we have our lower and upper boundaries in NumPy arrays, which we can work with now within OpenCV, which is based a lot on NumPy as its foundation matrix system, and within NumPy itself. So to find out what we're looking for in that image, in the HSV for the boundaries, so the colors that are being lit up by those LEDs, what we're looking for in there, we're going to use this to find the ranges. So the CV has a way for you to parse an image and then also find boundaries within that image. And that's what we call in range. So it allows what we call thresholding. So we simply put the two boundaries in and we run them about it, and then it finds the pixels and it creates a mask. It finds the pixels that have these conditions on it. So now that we have that mask, what we want to do is, and we only do this, so the difference, you're going to not see me do this in the OpenCV code. I do this next system, this next operation, because I want to show you in that, as we said in the HStack down here, when I go to the streamer and HStack everything, I want to show you what's going on in the HSV. Well, one of the quirks on HStack is you must have matching dimensions in your images that you're showing. So what I'm going to, and this gets important in lots of things if you want to show combinations. So what I'm going to do up here on this threshold image is I'm going to build an image, a mask. I'm going to build the mask into an image. And how do I do that? Well, I take the HSV image, right? And this is just saying this is what I want you to use basically if I just sum it out. And I'm going to do a logical operation, the bitewise, against it. So think of this as my matrix and my mask as a scalar. So I'm going to take my mask and I'm going to AND it bitewise. And so what that does is it's going to, when it finds something that is, if it finds a black space or an empty space in the threshold mask, it's going to wipe it out on the HSV image. And so what that's going to do is it's going to go ahead and show you just the HSV coordinates that match the mask in the threshold image. And that might be a little complicated, but another use case for this is, let's say I'm using a camera that, and you want to pay attention to this and things like that, that's thermal. And thermal is going to give me one dimension, and I want to show it off and I want to view that image next to a regular image, and I want to use NumPy to do that and all of our stuff. You're going to have to use a similar type of rebuilding image where the thermal information is the mask. And I'll go through that in a later one. We also do that in depth cameras, where we'll take that and we'll use this type of bitewise manipulation and so forth, and scalaring to build up a depth image into 3 dimensions and so forth. So that's what we're doing here. Okay, so the next step I want to do is I want to go in to do some image processing. Now, what NumPy is very good at doing is matrix manipulation. What NumPy is not good at doing is things that don't involve the entire matrix, right? So with that, we have Python, and Python has something called list functions, and list functions are very good to do targeted things in. And so what I'm going to do here is I'm going to go ahead and I'm going to turn this into a list. And what I'm going to do is take the threshold mask, and first of all, I'm going to use a matrix operation that says, go find me all the non-zero threshold, go find all the non-zero pixels in the threshold mask. So I do that. Now, because of the way I'm used to working, and you don't necessarily have to do this, but I like working on the in the NumPy image in the OpenCV space. So what I'm going to do is I'm going to flip, and we talked about this. I'm going to change this from XY in NumPy, and I'm going to also at the same time change this and transpose the axes, the XY axes. So I'm going to use a transpose system here. And then the last thing I'm going to use NumPy to do in all this, I'm going to have it change from a NumPy array to a list. And it's that simple. So you see right there within that, I've done a lot of powerful operations using NumPy, and it's really great for processing. So now I have a whole set of YX non-zero pixel lists. And like I said, you don't necessarily have to transpose. It's just the way I work. But these other things were very useful to use. So now I have a non-zero pixel list. So now I'm going to use list processing. And so if you noticed, if you remember back to when we were playing that, we have a shelving system. And that shelving system is in a region of interest itself within the formats of how, within the image that the camera is processing in the frame. And so what we're doing is we're using list processing to focus in on that, so that if something bright in the HSV spectrum comes up, and we'll see why we need that later on, we ignore it. So what we're going to do is pay attention to pixels only in this certain region of interest. So what we do here is on the x-axis, I say, I only want to see my non-zero pixel list now, and I'm going to call it output. I only want to see it in anything on the x-axis that is between 130 and 380. So if I look at my columns, I only want to see in my columns anything that's between 130 and 380 in that pixel thing. Now, if I go into my rows, then I want to do another operation here where I go in and I say, and again, so you see one here, that's my X, and then 0 because I'm YX. My 0 formatted item is I want on the column side to see anything above column 97. And so again, we built a tool for them that shows region of interest, and we use that tool and said, there's where it is. That's the region of interest in the pixel and so forth. It's as straightforward as a bounding box, basically, that piece. All right, so now we have an output 1, which basically focuses everything between 130 and 380 on our columns and 97 above in our rows. So now we have that shelf in focus, and we're looking for non-zero pixels there. So now this is totally unnecessary coding coming up here on this average piece, but I just wanted to take you through another NumPy manipulation, and I wanted to take you through a NumPy manipulation that uses mathematics. And so, and I'll tell you another reason, but let me just start with this and stay on it. So what I wanted to show you, and I'm not going to use a transpose this time. I'm going to show you, this is how, again, and we talked about, I'm going to take my list and I'm going to make it into a NumPy array. So I just come through and I say, go ahead and do this. Now, for those of you who are following this, I'm actually keeping this in a YX system. I didn't do a transpose, so it's going to be very much in the OpenCV YX axis. Now, so I go ahead and I put array, NumPy array, which is YX now. And then what I want to do is I want to crush down axis 0 and get the mean value of these things. So what I do here is I come across and I go ahead and take my array and I say, let's go ahead on the axis is 0, down my Y and my X axis. I want to pump out what the mean value is at. Why? Because I'm going to put a circle in the middle of the min max. That's all I'm doing. It's unnecessary. But what it's going to do is kick out the mean values for YX on this, and it's going to give you an average. And now these are in a float int32 format. It's going to spit out. Okay, so I don't want all those dot points out coming out. So what I do here is I use another NumPy function called asType. And asType lets me recast. And so what I'm going to do is recast and let it do all of its truncation function. And I'm going to say, let's take that float 32 and just make it an int 32 because I want the coordinates to be clean. Okay, I want them to be as clean as possible on the pixel. So that's what I did. So this is, again, like I said, unnecessary to do, but I did it just because we're talking about NumPy operations on this, and I can show you where that comes up on the system. Now, the other reason, let's say I did really want those mean values and why I made the exchange here, because I've imported 2 libraries already. In the pixel, in the list processing, it gives you a min max, but it doesn't give you a mean value. And if you want to get a mean value in list processing, you have to put in another library called statistical, I think it is. And so in that will give you a mean value. But if you have the tools there, like I do now with NumPy in there, there's no reason to import that library. So,
hey, Steve,
yes.
Sorry, can we just pause for like a quick?
Yeah, sure. My jaw is sore, so let's go ahead and do that.
Yeah, I wanna kind of open it up to see if any of our attendees have any questions about what you've gone over so far. If not, we can continue. No, not a problem. We are getting closer to the hour, so I just wanted to see.
Yeah, you know me. I have never made a webinar end on time, and I'm certainly not. And I apologize to everybody if I've bored them, but I just want to run through the code with you on it. So,
sorry. Let's just see if anyone has any questions. If anyone has questions, can you please raise your hand? Nope. Okay, I think we're okay to continue, Steve.
Either that or they're bored or I've answered the questions. I can't believe I've answered the questions. So I'll try to speed it up some. So using list processes, I find the max and min, and this is going to help me, as we said, get the ROI correct of that, of the region of interest within the shelves. So I get the min max pixels here. Now, if you remember, when the hand goes across, it dims the light. So what we do here with XCheck is we go ahead and we check to see what that max pixel is in min pixel, and it will start to shrink down when the hand goes over and it will contract the light. And so what we do is we do a check here, And if it's underneath 40 pixels, we go ahead and expand it. And we say, and we expand that out. So that we reset our min pixel so that we kind of hold that bounding box. Sometimes you'll see it creeps off the edge on the left-hand side, but normally it just holds it. The next thing is, just so we can see what's going on, I use the the OpenCV circle drawing function. So I come in and let's just talk about that. So what you want to do here with any type of circle is you give it the frame that you want to draw the circle on. And then you give it what are the center coordinates of your circle. Then the next function you have in here is what is the radius of that circle. So we're going to do something at 4 pixels. And so that's our radius. And then you set the color. So here we're setting the color to black. And then what you can do is, this is the thickness of the line, but if you go into the negative spectrum, you're saying fill it. And so what I'm going to do for a radius of 4, I'm going to fill in that circle, and that's the -1. And that's how the circles are done. So in this one, I'm going to show where the midpoint is, where the min point is, and where the max point is. You finally now get down to where you're going to run the object detector. Well, first of all, you're going to draw the ROI. So the initial function we talked about, we're going to go out and find the ROI, which is the region of interest that's lit up by the LED on the system. So we're going to use that function back up here to draw, and we supply it those min, max, and max parameters that we have. And we go ahead and we draw that region of interest. So that's the next thing we're going to do, is draw the region of interest based on lit up LED. And so we do that. And then we come in and we get our object detection results. So now we've come back and, everything that you usually see compacted, now we're ready to get our results back. Then we go in, we're going to parse our predictions. So the first thing we're going to do, and this is to really get the overlapping rectangles algorithm on this and to show it. So first we're going to get our prediction results, and for that, we're going to get our box on our rectangle. So we're going to get the bounding box of the hand detector. And then from there, we're going to set up our left-hand corner and our upper left-hand corner and our lower right-hand corner. We're going to get the coordinates that. And remember, I'm using this lazy guy class here called point. And so it's going to give me a nice OpenCV point that I'm going to use to draw rectangles with. So I come in here, I get my points for my L2 and R2. And then I come in and I take a look at rectangle 1, which is what's returned from my region of interest. And I go ahead and I pump through and I get my L1 and R1 points there. And so then what I'm going to do is go ahead and send that to the overlapping rectangle algorithm. And this actually will go and do the checkpoints of these points to see if they are in a true or false condition. So after all this, finally, we have the true or false condition, and we come in and then we use this to, if they overlap and this returns true, right? Then what I do is I use my grab status and I change the wording here to component grab. And then I change my color scheme so that it will show it as green. Then we come in and we use the standard markup image function. But the difference here is, instead of using the generic things that come out of the object detector that we set in our class for our model classes, what I'm using is some customized colors. So I make colors equal colors here. And then I just go ahead and all this is a normal. So if I hadn't grabbed anything, it'll come no component grabbed on the text. If I have grabbed something, it'll say component grabbed from the tray. Difference than you normally see is I'm going to now stack, so you can see what's going on in the HSV spectrum. I'm gonna stack my frame, which is the output of all my object detection and my overlapping rectangles and all that. I'm gonna put my frame out there, and then I'm gonna go ahead and also put my threshold image. So I'm gonna get a combined NumPy array of these images using what they call the horizontal stack function in NumPy. And then I'm going to send it to the streamer. And then it just is a normal type of system. So I'll go ahead and we'll let it run through again so you guys can see it, and this time see it with the HSV spectrum. And what you'll see is that blob of data I'm getting, and this is what Eric commented on 2 days ago, is it's not very big. It doesn't have to be that very big for you to get all the information in. And you do it isn't very big because you're trying to pull out all the noise you can. And I'll talk more about that. So I think it's called what was it? Program program. So we'll go into that. I'm going to do my alwaysAI app start, and I hope that I've configured this to save time. And so let me go ahead and return that. So now what you're going to see is here's the HSV spectrum working. And like you said, it's not much data that's in here. And people say, well, why? Well, we know one of the problems they have in here on this thing is the core of their LED is white light, not really red. So, but it works. And you see there's very little blob information coming through, but you still have enough, as you can see on the circles being done here, to get the information to pick up where that region of interest is. So, and you can see on my laptop, I'm running, you know, at the 40 millisecond range, and I was in the 50 and 60 millisecond range on that. And I think what I wanted to show you here, just so you can see, is you know, you're running about 20 frames per second on that. And if I go back up, you're about the mid 13 frames per second on the Raspberry Pi. And so what I'll say is I appreciate your patience on this long one, but I'm ready to go with questions now. So thanks. That's the basic application today.
Thanks, Steve. Does anyone have any questions? Okay.
Yeah, I think I put the audience to sleep. So I did want to see a practical use of OpenCV. So.
Well, okay. I'm getting a couple comments, like someone said, cool, fun little demo. So you didn't put the audience to sleep, Steve. Okay. People were excited to see it. Okay, well, if, let's see. Leo Cohen said, this is great technical content, and he's definitely not sleeping.
Okay, good. Like I said, we want to make sure you get out there and see a chance to use a practical application that we worked with. That was the point here.
Yeah, definitely. Well, okay. So
I did want to comment on one of the things that Eric said on the NVIDIA Jetson. I think what you're going to start to see on some of these applications when you pair the Pi, and particularly in single shot detectors like what we're using here, the MobileNet single shot detectors, that the Pi is going to outperform the NVIDIA unless you do something like TensorRT. And even then, we think that from what we've seen on our things, that TensorRT will probably be pushing about the same, near that speed. Okay, so just something that not necessarily going out and buying the NVIDIA Jetson are you going to be able to outperform the NCS2 with the Pi. So I just wanted to make that one comment because we're getting all this thing benched, as Eric said, and getting everything done, but we're not necessarily seeing extreme performance gains, or even sometimes we see less performance out of that system. And I just lost NVIDIA as a partner, I think, talking here, but I'm sorry about that, Kamal. So.
No. Hey, there's a question from Jose Luis, and he said, is it better to work with the lab color space and HSV? When is it better to use lab versus HSV?
Trial and error. I think it depends on the lighting stuff, and that Learn CV from Sache. There's a one, and like I said, I'll get that passed off to you, Kamel, so you can give. It talks a lot about that, but a lot of times unfortunately, this is what we call the crafting part of computer vision, and you just want to try the different spectrums. And my gut is if you're in sunlight, HSV is going to be better. That one I can automatically tell you is going to happen. So if you're out in the real world and you want to find something more on the HSV, it is going to be better and so forth. That's what I've seen in sunlight where it's better.
Okay. So there's actually a question by David Dodds, and he's asking if he's able to get the color code listing as a file somehow. But
Yes.
David, can you elaborate on your question a little bit?
Okay, first of all, can you hear me?
Yeah.
Yep.
Okay. It's not clear whether the intention is to have that file that we've been looking at today available for download from your site, either very soon or soonish. I missed a little bit at the beginning of the session today. Since I'm new, and this is my first day
Yep.
on a Hacky, I don't know what the protocol is for doing things with you guys, getting code, getting the video that you were just showing, and so on. So I would like to hear what the protocol is for people to do this.
So yeah, so again, we have all of our starter applications we're showing up for, and those are contained with the with the alwaysAI system. And then our new protocol is, and it's fairly new, David. So don't that we're starting to do as we do these hacky hours. We have a GitHub, and we make those available. And what we haven't done good that I'm going to talk to the team about is putting the Apache license plate thing up. But our intention is to have them, and this particular one has an Apache license with it. So you can download and use the code and use the system. So what I'll do is I'll show you again. If you go in, so we have this nice little GitHub right here underneath alwaysAI. So it's GitHub alwaysAI.
Your screen.
Oh, so David, let me do things. This is why I have Eric. And by the way, this happens at our stand-ups also with me. So anyway, so we have this alwaysAI Git. And so if you go down, this is the one we use today, the Hacky Hour, and you can just clone the repository and all the code is there. And I think, and if you even look into the code section, you'll find that the video is also there for you. So it's a complete code set for you to take a look at and work with. And then if you have any other questions on stuff, or maybe you want to show you how to do additional tooling and things like that we've used, we have a Discord channel to go to too. So if you go down here and it tells you within this system, sorry, that sometimes I find them. So if you go down, we have this Discord community, which is like Slack, right? It's the gamer Slack. So video gamers like me, we use Discord all the time to talk to our compatriots. But we also use this within alwaysAI so that you can talk and you can get help. And so just go on there and we can help you with more questions. And it's right there in actually the GitHub section with each one of our code. So if you go back and look at last week's, I think last week's was, there should be one from last week. Where was last week's?
Posture corrector?
Okay, somewhere up here is the posture. I don't know where it is. But anyway, there it is. So last week's is sitting right here. So if you wanted to go and go back and look at last week's hacking session on posture correction, it's right there. But so anyway, David, long answer for a question that could be more concise is we have everything for you up in those Git, and they're Apache licensed. And I will make sure people put the license files in that, and it's something we'll work on doing. They should be there. But we encourage you to use it and make those as part of your programs.
David, hopefully that was helpful. Do you have any other questions, David, for Steve? Okay, I'm going to take silence as a no. All right, and if there are no other questions, I think at this point we're ready to close out. I just want to thank everyone for joining Hacky Hour, and we do this every Thursday at 2 p.m. So if
the next one we're going to have, and it's just we have a special one next week. Belina is going to be showing up, and they are they do IoT, and they do mass distributions and so forth. So as the next step in your application, once you get it all set up and you want to deploy it, Belina is a great partner in how to do that. And they have a lot of other tricks up their sleeves, and you'll find David very interesting. We actually copied their Hacky Hour. They were the first to have it, and we decided it was a good format. So you may want to sit on some of theirs, especially if you're into hardware. They do a lot around hardware, so it's a lot of fun. So anyway, sorry, Kamal. I just wanted to announce that because it is a different format.
No, that's awesome. Yeah. And David just posted saying he needs to get his demo ready. So
yeah, like I said.
So yeah, definitely join us next week for our Hacky Hour with Belina. But as I was saying, we do this every Thursday. So this is an opportunity for you to come out and learn more about computer vision, more about alwaysAI, and meet other members of our community, our engineers, and ask questions, be interactive. So yeah, thank you so much for joining, and I'll see you on the next one. Bye, guys.